What's going on YouTube? My name is Johnny Bannon with Intrepid Technologies, and today will be the first video in a series of 8 videos going over OSPF following Intrepid Technologies Confluence how-to page. So click that link below and let's get started. Alright guys, like always, the first thing we're going to do is go to our Confluence page, so I'm going to bring that up. We're going to go to Spaces How-Tos, which should be in the link directly below. Then we're going to go to Cisco, OSPF, then OSPF single area configuration. So this will be the first how-to we go over. As you can see, it gets more complex as we go down. Then I also have a glossary for OSPF because there's a lot of terminology that goes in to this interior gateway protocol. So if you watch my previous EIGRP videos, you know that EIGRP is what we call an advanced distance vector protocol, right? It uses K values and next hop logic to actually create its EIGRP topology table, right? OSPF, however, is based on a database, right? And we call that the linked state database. So in OSPF areas, every router should have the full database of all routes in its topology, well, we call it OSPF database, and in its routing table. So what do we mean by that? So OSPF, right? It relies on a spine-leaf-spine hierarchy. This hierarchy requires a backbone area. So this backbone area is considered the spine, right? And from that spine, all of our other leafs or our other areas connect to. And within those areas, every single router should have the same link state database. Okay? So for this how-to, we're going to focus on single area configuration. So we will just be configuring OSPF routers in the backbone area, which OSPF defines as area 0. In this area, we have two types of LSAs that are created and sent, right? So LSAs are those link state advertisements that create the link state database between all routers. So as we can see here, OSPF routers do something called a link state database exchange. And that's where we're going to send all of our LSAs. And there's different types of LSAs. So on just area 0, a single area configuration, we're just going to create type 1 and type 2 LSAs. And if we're working in a broadcast network, which is what we're going to be working in, the hello is exchanged, and then OSPF is going to choose between a DR and a BDR. This stands for a designated router and a backup designated router. And the designated router is going to receive all the LSAs on this multicast address, and then send them out to the rest of the OSPF routers in that area. And then the backup designated router will receive LSAs on this multicast address, .6. Okay guys, I think I went over a very quick overview of OSPF, right? The important thing to know is that OSPF is separated into areas and that it's a light leaf spine hierarchy, which essentially means that everything needs to be connected to the backbone area. And that OSPF runs by using LSAs, link state advertisements, to build a link state database that is the same between all OSPF routers, okay? So in this how-to, I'm going to be using my CCIE Enterprise Lab environment. For this how-to, we'll just be configuring router R8 and router R10. So some things, guys, on my baselines that I have in here. So when I made these how-tos, I don't know if I put the date, but January 31st was the last time it was updated. And that was actually just to put this picture in. So I made these how-tos maybe 3 to 4 weeks ago. So as I've been studying the CCIE, or getting ready to take the CCIE lab, my baseline constantly gets updated. I've added a few more applets and a few other things in the actual baseline of all my routers. So if you want my most current baseline, you have to go to my GitLab, which will also be in the link below this video. This GitLab holds my repository I use to manage these devices, right? To do some network management. So CCIE Enterprise. And essentially this repository just uses Ansible, right? I use Ansible to manage all my baselines and to push some basic configs to it, right? I have these playbooks here, named ERGRP, no Ospf. I pretty much just make stuff that I need. So these are my most current baselines. As you can see, I just added this. So if we go into actually R2, this looks a lot different than the baselines I have on my how-tos, guys. So for this video, like all my videos, the first thing I'm going to do is actually clone that repository, okay? So I'm going to go back to GitLab. We're going to go to the CCIE Enterprise project. I'm going to hit clone of HTTPS, go back to VS Code, go to View Command Palette, hit Git Clone, so apply it a URL, choose the location for this repo, which again is just a folder. We're going to open it, and now here are all my baselines. So in case you guys are running through these labs with me, that's how you can get the baselines for all your devices. Let's go back here, exit out. I'm going to bring this over to the side, and I'm going to follow this how-to by the steps in here. To make sure that this how-to is actually good during this demonstration. So you guys can't see it, but I have my Confluence how-to page over to the side, right? And I'm just following along. So it says the first thing we're going to do is turn on all routers, set up our GNS3 environment, and we're going to be configuring between R8 and R10. Again, this is single area Ospf. So this should be a quick video, guys. So now on this configuration, following the how-tos, in R8, we're going to configure Ospf under the routing process. Don't know what that is. Just ignore all this multicast stuff, guys, here. So to do it under the routing process, right, we type in router Ospf, and then we give it a process ID. This process ID is local, okay? Meaning we don't need this to match between routers to actually create Ospf neighbors, which is different than ERGRP, which when we create that routing process, the autonomous system number needs to be the same between all ERGRP routers. This process ID is just local. So then I'm going to give it a router ID. If we don't set this router ID, then it's going to go with the loopback address, the highest loopback address as its ID. All right, looks like we already have Ospf running on these. Yep, so what I'm going to do is show you guys that I have an applet that actually clears out any routing process. It's right here. It's called baseline. And I run this applet by typing in this alias, baseline. And it goes through and gets rid of all routing processes. And it uses actually rejects regular expression to do that. So it doesn't matter what process ID it is, what number BGP or ERGRP, I can get rid of any routing process using this alias baseline, which runs that applet. I'm going to do the same thing on router 10. Then I have to run another one called interfaces, which essentially just makes my interfaces come up again, gives them IP addresses. Again, ignore all this PIM statements, guys. All right, now let's go and do some Ospf configuration. Again, local process ID. We're going to actually set the router ID. And then we're actually going to do the network statement, just like we do in ERGRP. So just like in ERGRP, this is only going to advertise, let's see, 255, active interfaces, right? So this specifies what IP address you want to advertise. And then this prefix that I'm setting here actually needs to be assigned to an active interface for it to be advertised. As you can see here, it's exactly the same as AGRP up until this point. So right here, we're designating that these networks are going to be in the backbone area, which means that this router should be creating type 1 and 2 LSAs to be advertised. So if we go to R10, let's go ahead and do the same thing and see our OSPF neighbors come up. So according to our how-to, we're going to actually configure OSPF under the interface. So we're going to go into all the active interfaces, which on R10s is gig 00 in this loopback. We're going to say IP OSPF 1 area 0. So this also will start running the OSPF process, just another way to do it. So we should see our neighborship come up. And as you can see here, the neighbor ID is 8.8.8.8, which we hard set on R8. And then this one is the highest loopback address on R10. So if you do show IP interface brief, include up, highest IP address. All right, guys. Now that we see our neighborship come up, we're going to do some basic show commands. So show IP OSPF neighbor. So as you can see here, I actually have two neighbors on R8. Let me just go ahead and take Miami down so we can just see one neighbor, right? But I'm doing this so we can actually follow my how-to the way it should be. So remember to make sure all your routers, I'm using the term baseline to say that it just has IP addressing, right? No extra routing processes configured. So now let's bring up R8 again, run those same command. So essentially what we see here, guys, is even though R5 is now down, that dead timer needs to expire for OSPF to actually bring that neighbor down. So it's kind of good that we did that, right? See some extra troubleshooting. Boom, now it's gone. See, dead timer expired. So it has a 40-second dead time, guys, as a default. And we just waited that 40 seconds for that neighbor to come down. Okay. Now that we did that, let's run another basic show command. It's going to be show IP OSPF database. All right. So this type 5 is from all the way over here, guys, R9. When I was neighbors with R5, I actually got that type 5 sent to me. But if it was just R8 and R10, all you would see is this type 1 and this type 2 LSA. And that's my bad, guys. I should have baselined these routers, so it could have been a lot simpler. But here you go. Type 1, type 2, which is all the LSAs created in the backbone area. If we look at R10, we should see the same database, because we know that all routers have to have the same link state databases for OSPF to have full conversions within the network. And it looks like we do. Some other basic show commands that are available to us is the show IP OSPF interface command. So this is going to show you what network type we have, broadcast. It'll show you what state this is. It's the designated router, the address, the router ID, just some basic OSPF information. The hello and dead timers, right? The defaults. So if you're wondering about this network type, guys, don't worry, we'll get to it. I believe in multi-area configuration. There's this broadcast network type, and then there's a non-broadcast network type. And when you're in a non-broadcast network, the hello and the dead timers actually change from 10 to 40 to, I believe, 30 to 120. And it's something you actually have to set. So an example of this is this DMVPN network, right? When we run OSPF between here, I actually go into the hub here, into the tunnel interface, and set it to a non-broadcast OSPF network. So I think we'll see that in multi-area configuration. So don't worry, we'll get to it. And now, let's actually look at the routing table. And we can see our OSPF routes right here. Administrative distance is 110, and that's the metric for OSPF. Which, if you want to get into that, guys, on my Confluence page, all like the basic information for OSPF I have here in this PDF, okay? And if you want to learn a little bit more in depth. So now, following this how-to, we're going to shut down the interfaces. We're going to start a Wireshark capture, and we're going to actually see this neighborship come up. So we'll shut gig 00 on R8. Okay. Start this capture. So as we can see here that router 10, right, it's still sending OSPF hello packets. And the destination is that DR multicast address. So this is the default one OSPF uses, this multicast address here, to actually send hellos. And then in that broadcast network with multiple routers, when we choose the BDR and DR, that is the designated router and the backup designated router, we'll start using 224.0.0.6 for the BDR. So now let's no shut the interface. Let's see these neighbors come up. So we should see an ARP, hello packets, and then once they become neighbors, right, they're going to start doing their link state database exchange. So the first ones that get sent are what we call Lsdbs, link state database descriptions. So in here, let's open one up, source from R8. If we go to the header here, the OSPF header, it gives us some information, right? Says, hey, I'm a backbone area. So if our neighbor wasn't part of this area, we would not actually become full neighbors. It shows you the router ID, your database description. I don't know what this is, but it's all good information, right, guys? So once they agree on their database descriptions, one router is going to request all the routes, right? It's actually going to say, hey, tell me about everything on your network, okay? So it's saying, hey, tell me about these guys. So this is actually the R10 router ID. And then this is our ID, right? Right here, excuse me. And then from that request, R10 is going to update and say, okay, here's all the networks I have. And now it's going to show you all the networks. And these are the type 1 and type 2 LSAs, which is all we should see on area 0. They're going to send those updates until we get here down to the acknowledge saying, hey, we have now exchanged all our LSAs, and now we are fully converged. As you can see here, every single type, LSA type, is in there. All right, guys. So that's all we have for this video. Single area configuration for OSPF. It's super easy, super simple. If you have more of an inkling to learn, again, there's many resources out there on the internet. I use INE to study, and I also use a book called TCP/IP Volume 1. Essentially, I use that book and INE to make all these how-tos, okay? So again, from everyone here at Trumpet Technologies, thank you for viewing, and remember to keep learning every single day.